This is Harry Burns. He's standing in the flash fire facility at the Protective Clothing and Equipment Research Facility at the University of Alberta, where we do full-scale evaluations of fire protective clothing. Most commonly, this system is used to evaluate industrial coveralls used for flash fire protection, but it can also be used to evaluate military clothing, wildland firefighters clothing, structural firefighters clothing, and a wide variety of other fire protective clothing. There are only a handful of facilities in North America that are equipped to run full-scale fire tests on protective garments in this way. Full-scale tests allow us to evaluate garments in their entirety, to evaluate interactions between the different parts of the garments, to evaluate features that are difficult to evaluate in smaller scale. Over the surface of the mannequin, there are 110 sensors. Each of these sensors has a temperature measurement on the surface of the sensor, which is then used to determine how much energy was transferred through the clothing to the surface of the mannequin, or from the flames to the surface of the mannequin. Once we know how much energy was transferred to the surface of the mannequin, that is put into a computer model of human skin, and that is used to evaluate how much burn injury might have occurred in that exposure. This system started in a project in the 1980s to evaluate fire protective coveralls for industrial use in Alberta. Researchers in the Department of Mechanical Engineering and the Faculty of Home Economics at the time, currently the Department of Human Ecology, were tasked with putting together a system to evaluate coveralls that were currently available on the market to determine which would provide suitable protection for workers. The precursor to the industrial flash fire tests performed in this room were a series of children's sleepwear tests that were performed on a child-sized mannequin. The child-sized mannequin was later retrofitted to more closely match this system and was joined by a female mannequin to further assess garment design and garment fit factors in full-scale tests. Students and researchers today use this system to evaluate designs and complete garment systems to determine how the interactions between components of the systems and the fit of each part of the garment can affect protection in large-scale fire experiments. This system is also integral in development of temperature and energy sensing techniques and instrumentation for other tests that we perform, as well as for development of international standards for performance of fire protective clothing. The flames in this test are generated to be very fuel-rich and generate a lot of soot. This keeps the flame temperature down to nominally about 1,000 degrees Celsius and causes a lot of radiant heat transfer to the surface of the mannequin or to the clothing the mannequin is wearing.